This module focuses on the evolution of spark plugs from the first crude plug of the 1800s up to the high-tech spark plugs of today. The first known spark plug was used in a crude internal combustion engine back in 1860 by a Belgian engineer named Etienne Lenoir. Lenoir is generally credited with the invention of the spark plug. Other historians say it was Edmund Berger in 1839. Early patents were also filed by Nikola Tesla, Sir Oliver Lodge, and others. There were other devices used to create a spark back then, such as the hot tube ignition, the wipe spark ignition, and the low tension igniter. None of these technologies proved to be very reliable. In the early 1900s, the French were leaders in spark plug production, although these early spark plugs were also unreliable. Autolite entered spark plug production in 1936 when the Electric Autolite Corporation began producing spark plugs for Chrysler, Willys Overland, and other car makers. Before we continue, let's take a look at the important components that make up a spark plug. Spark plugs consist of the following: the insulator with ribs, the resistor which blocks radio interference, the center wire or center electrode, the shell with gaskets to seal the insulator, and the side wire. It didn't take engineers very long to figure out that the wire should pass through an insulator tube and into the engine. The first threaded spark plugs appeared around 1900 and used pipe thread or a gasket to seal it to the combustion chamber. The early spark plug insulators were made from low-grade ceramic and porcelain, similar to grandma's dishes. However, this material had a relatively low melting point, low mechanical strength, and was not a good electrical insulator at high temperatures. These early plugs were also susceptible to thermal shock and would often break or shatter inside the cylinder with disastrous results. Other early insulator materials included mica, wood, Pyrex glass, and many more. Mica was the standard for quite some time, but it was far from perfect as it would disintegrate at high operating temperatures. At the beginning of World War II, the United States Air Force met with spark plug makers to show that much of its fleet was grounded due to unreliable spark plugs. The U.S. spark plug industry had to quickly step up with more robust ceramic insulators. Just before World War II, a major development was the introduction of leaded gasoline. This required another evolution of the ceramic insulator of the spark plug. Leaded gasoline was blended to improve its octane properties, which prevented knocking. But this fuel is detrimental to the insulator and the electrodes of the spark plug. More research on ceramic and electrode materials was required. The solution was to make the insulator out of an aluminum oxide mix, which was more resistant to the effects of the leaded fuel. When the first spark plugs were invented more than 100 years ago, the center electrode was made from a solid material. This application of metallurgy worked fine for more than 50 years. The center electrode really began to evolve in the 1970s. In the late 70s, engine development reached a stage where the heat range of the conventional spark plugs with nickel alloy center electrodes was unable to cope with the demands of modern engines. A plug that was cold enough to handle the demands of high-speed driving couldn't burn off the carbon deposits caused by stop-and-start driving conditions. This would foul the plugs and make the engine misfire. Similarly, a plug that was hot enough to run smoothly in town could go into pre-ignition when used for extended high-speed driving under load. Spark plug manufacturers answered the problem with a center electrode that carried the heat of combustion away from the tip more effectively than what was possible with a nickel alloy center wire. Copper was the material of choice for the task, and a new copper core center electrode was made. In 1980, the Autolite team produced its first copper core center electrode spark plug. Pure copper melts at close to 2,000 degrees Fahrenheit and has tremendous electrical and thermal conductivity, but it's very soft, so by itself, copper would make for a poor spark plug electrode. That's why when we describe our copper plugs, we refer to them as copper core, because only the core of the electrode is made of copper. The outside of the electrode is a nickel alloy. By using a copper core center versus a standard material, we can conduct more heat out of the combustion chamber and into the cylinder head and coolant passages. This helps minimize electrode oxidation and assists in lowering combustion chamber temperatures. And that minimizes the risk of pre-ignition and helps reduce NOx output, a harmful greenhouse gas. In the 1980s, this was quite a breakthrough in spark plug technology. Even today, you will still see a copper core plug in a few applications, but the original equipment manufacturers will specify a 25 to 30,000 mile change interval for conventional copper core plugs. You should never use a copper core plug in a DIS or distributorless ignition system application. The sidewire is not designed to reverse fire in the way that a plug like the Autolite Double Platinum or Iridium Enhanced Autolite XP spark plug can. Using a copper core or single platinum plug will cause premature electrode wear on half of a vehicle's spark plugs in as early as 18,000 miles. Platinum is an extremely rare metal that occurs in only 0.003 parts per billion in our Earth's crust. Platinum is more precious than gold or silver and is much more resistant to oxidation than most other metals. It has a melting point of over 3,200 degrees Fahrenheit and has a high resistance to chemicals that exist in the combustion chamber. Plus, it's a good conductor of electricity. So why do we use platinum in a spark plug? As ignition systems evolved into electronic systems with fewer moving parts, a longer life spark plug was needed to match the durability and performance of these new ignitions. Platinum spark plugs provide a center wire platinum firing tip for reduced gap erosion, fewer misfires, better performance, and more durability than copper core plugs. A platinum tipped center electrode resists oxidation and arc erosion, and it will maintain a constant gap over a much longer period of time versus a copper core spark plug. A platinum electrode spark plug tip can be as small as 0.8 millimeters and is considered a platinum fine wire design. So why do we need a double platinum spark plug? As the ignition with a distributor evolved into a distributorless system, it fired the spark plugs in both directions. This means that half the spark plugs on a vehicle fire from the center electrode to the side electrode, and the other half fire from the side electrode to the center electrode. A double platinum design helps to protect against sidewire erosion from the plugs that fire from the side wire to the center wire electrode. If your customer has a coil pack DIS ignition, chances are it came from the factory with a double platinum spark plug. Iridium is a very hard, brittle metal in the platinum family that has a melting point of over 4,400 degrees Fahrenheit. Iridium is the most corrosion-resistant metal known to man, even under temperatures as high as 3,600 degrees Fahrenheit. It's also a very rare element. By comparison, platinum is about 10 times more common in occurrence. As ignition systems further evolved into coil over plug and coil near plug systems, it was important to develop a more efficient spark plug that required less voltage to fire. You can imagine that installing individual coils for every cylinder is a difficult and expensive task. The coils need to be made smaller, with manufacturing costs under consideration, and are often placed in tight underhood locations. The maximum voltage output of the smaller coils is lower, and plug manufacturers needed to find a way to lower the voltage requirement from the coil for the spark to jump the gap. Engineers discovered the best way to reduce firing voltage was to reduce the diameter of the center electrode. As the diameter of the electrode grew smaller, manufacturers needed a superior alloy to handle an increased amount of arc erosion over the smaller electrode diameters. Today's iridium alloy spark plug electrode can be as small as 0.4 millimeters. By itself, iridium is not as resistant to oxidation erosion as a platinum electrode until it's blended with other metals like platinum and tungsten. Some manufacturers now specify iridium fine wire technology in coil pack DIS applications because of its superior performance and durability as compared to large wire platinum designs. In any event, iridium and fine wire plug designs are the technology behind extended spark plug change intervals. It's important to select electrode materials that are naturally resistant to oxidation as well as electrical arc erosion. That's why we use expensive platinum and iridium blends to create effective alloys for the job. Here's a quick rundown of some of the other specific metallurgy involved in modern spark plugs. Of all metals in their pure form, tungsten has the highest melting point, nearly 6,200 degrees Fahrenheit. Tungsten oxidizes at lower temperatures than other metals and would be a poor performer all by itself. But if you blend iridium with platinum and tungsten, it creates an alloy that combines and exploits the benefits of each material. Nickel is a corrosion-resistant element that is often combined with copper to form a copper core spark plug electrode. It's also used in plated form to provide a corrosion-resistant spark plug shell that resists seizing in an engine spark plug threads. So let's talk about how this metal technology applies to the Autolite line of spark plugs. Autolite copper core spark plugs have the following features: a copper core center electrode and a nickel chromium alloy side electrode, which provide good heat dissipation and durability. Autolite platinum spark plugs feature a platinum ball on the center electrode for greater durability, longer life, quicker starts, faster acceleration, and fewer misfires than copper core plugs. They also provide cleaner firing over a worn spark plug. Autolite double platinum spark plugs have a platinum pad on both the center electrode and the side electrode for durability in DIS-equipped engines. Double platinum gives you superior engine performance, longer life for improved fuel economy, and easier starts versus standard plugs. In a gap wear comparison between Autolite double platinum and standard copper core plugs, the double platinum had virtually no gap erosion. We also use a proprietary platinum ball welding process to attach the platinum pads. Autolite XP iridium-enhanced fine wire spark plugs are an excellent choice for any engine, regardless of the ignition system an engine might use. And here's why. XP plugs have a proprietary platinum ball sidewire that allows them to be used in a DIS engine without gap wear issues. They also feature an iridium-enhanced center electrode with 0.6 millimeter fine wire design. This produces a larger flame kernel and more complete burn than a standard spark plug. Other features include a nickel-plated shell for corrosion resistance and a multi-rib ceramic insulator for protection against flashover and misfiring. The XP Extreme Performance is one of the most high-tech spark plugs on the market and is loaded with technology. You can see there is a lot of science and technology engineered into a modern spark plug, with some pretty expensive metals and materials involved. Keep that in mind the next time a customer asks for the best spark plug or wonders why they cost more than in the past. I hope you learned something valuable today about the evolution of spark plugs, their metallurgy, and their technological differences. Thank you for your time.